As we know that we require the software in this computer science field, and every software must have a good design so that we can able to communicate with him. Okay, so as if a good software is user friendly, then and only then we can use that software properly. So for making a software user friendly, we require some sort of designs, and the architecture must be good. So here every software must have some type of the design pattern and a framework which make them good for all the people. So friend, I am Professor Rushikesh Chikane from Pratibha College of Commerce and Computer Studies. Welcome you all in this new concept, that is software architecture and design pattern. So here we will start our lecture. So as we know that, so first is nothing but what is a software architecture and what it is not. Okay, so as we know that it is a set of the structure needed to reason about the system which comprise the software elements, relationship among them, and the properties of both. That is nothing but whenever we are saying the software architecture, it means what the elements which are present in the software and the relationship of in those in those elements. So the elements which are present in that software, how they are going to communicate with each other, what type of the relationship they are having, how they are passing the data from one place to another place, that is nothing but a software architecture. Okay, so architecture is a set of the software structure. As the new definition is that a software architecture is nothing but it is a set of the software architecture. So we say that a structure and the architecture, there is a difference between a structure and the architecture. Many of things that a structure and a architecture is similar, we can say that same, but it is not like that. A structure and a architecture is totally different. So here we can have one type of the example. Suppose we are making one building, or suppose there is a builder, we who want to make one building. So in that building, suppose we are having 1 BHK flat, 2 BHK flat, and some 3 BHK flats. So as we know that the structure of 1 BHK flat, the structure of 2 BHK flat, and the structure of 3 BHK flat can be different. Means the structure of all the flats are different. That is 1 BHK, 2 BHK, and 3 BHK. But comprisingly, those 1 BHK, 2 BHK, and 3 BHK forms one building. So that building is nothing but the architecture of the software, whereas the plan of 1 BHK, plan of the 2 BHK, and the plan of the 3 BHK is nothing but the same. So we can say that those are nothing but the structure. So here we can say that an architecture have the set of the structure, and architecture can have the combination of multiple structure. As we know that the building has 1 BHK, 2 BHK, and 3 BHK flat, means every flat has a different structure, but a building combines those all the structures and make it complete building. So the same thing is getting followed in this software architecture. Here a structure is nothing but, we can say that simply it is a set of the elements which are held together by the relationship. Again, a set of the elements, we can say that the flat is 1 BHK, then we are having one hall, one bedroom, and one kitchen. So all these things are nothing but the elements which are held together by that 1 BHK. If we are having a 2 BHK, again we are having one hall, two bedrooms, and again that kitchen. Again those four elements, that is each and everything which is in that flat is nothing but the elements, those are held together. So that forms a structure, and when we combine all those structure, it will form the architecture. So architecture and a structure are basically two different things. Okay, architecture and the structure are basically two different things. Here we can say that a structure is nothing but it is simply a subset of the architecture. Architecture is a last thing, whereas a structure is a part of the architecture. Next, software systems are composed of many structures, and no single structure hold claim to being the architecture. As we say that a building has many structures. A building has many structures means as it has 1 BHK flat, 2 BHK flats and the 3 BHK flats. So every flat has a different structure. So here we can say that a software system is nothing but it is a suppose a building, then every flat has a different structure. So software system is composed of many structures, and here we cannot say that if I am having the 2 BHK flat, then the structure, whatever the structure of my flat is having, that is the complete structure of the building. I cannot say that. Okay, because my building can have the more flats, also it has the more other amenities also, and then those flat structure and those amenities is nothing but the complete building. So here we cannot say that the one type of the structure can be a complete system architecture. Okay, so here no single structure hold the claim to being a architecture. There are three categories of architecture structure which will play an important role in the design, documentation and the analysis of the architecture. Okay, so what are those three structures? Look here. First one is nothing. First one is nothing but some structure partitions the system into implementation units. Or thing is nothing but here we can divide our system into the implementation unit, that is in a smaller units, and those smaller units are nothing but the module. Okay, so modules are assigned a specific computational responsibilities and are the basis of work assignment for programming teams. So here modules, whatever the basic smaller unit we are having, that is nothing but a module, and those modules are assigned some specific computational responsibilities. Okay, so here example, for example, we are having that example, that is suppose we are having a large team of the software development. So at that time we can we can assign the works into the team. Suppose in my team we are having 30 people, and all those 30 people are actually working on a project. So here all those people are not or they are not having the same type of the work. Here we can distribute the work into the group of the people. Okay, suppose we the 30 people are working on a same project, so at that time I can assign some responsibilities to 5 people, that they must gather the data. Again, those next 5 people can design for the system. Next 5 people, if they are good in coding, I am saying that okay, you 5 people make the code. Then next 5 people, I can say that okay, you are going to test that particular code. And the last 5 people are, they are trained for the implementation purpose or for the maintenance purpose. So here we can say that we are having the group of the 5 people. Okay, there are 5 people in a group, and they are doing their job, but the job is totally regarding for that, or the job is totally related with that specific project. So here the project is nothing but I can say that it is a system, and which is get divided into the smaller units. As here I am dividing my project into the group of the people, that is some people are working on the data requirement part or data gathering part, some people are working on the data designing part, some are working on the development part, some are designing we can say that working on the testing part, and some are working on the implementation part. So here all those peoples or all those groups of the people are nothing but the module which are working on that particular project. Okay, so as we are having the example, that is team A works on the database, team B works on the business rules, and team C works on the user interface, etc. Okay, so here all the peoples who are working on that particular system, all those people are get divided into the smaller teams, and each and every team is nothing but the module. Okay, so in large project these elements modules are again subdivided for the assignment to subteam. Now suppose we are having the group of the 500 people. So at that time, suppose if we are having the 5 teams, that is each team contains 100 people, again we can divide those 100 people into again the smaller team. Again, suppose we are having 20 people group. Okay, so in each group we are having the 20 people. So here we are dividing the large project into the smaller team or the sub team. So again, those sub teams are nothing but in this case those subsystems or those sub teams are nothing but the modules, and they are going to implement your all the work into the system. The structure that capture that decomposition is a kind of the module structure and the module decomposition structure in fact. So here we are going to divide that system into the smaller part, and again those smaller part into the sub smaller part. Okay, so this kind of the module structure is nothing but the decomposition type of the module structure, because here we are decomposing our system into the smaller part. Another kind of the model structure emerges as an output of the object-oriented analysis and design. That is nothing but the class diagram. So every one of us aware that of the class diagram. So here in a class diagram, here we can say that this class diagram contains the name of the each and every module. So whatever the module here we are having, those modules are nothing but in this case we are saying that it is a class, and whatever the responsibilities of the module has, those responsibilities are shown by that particular class diagram. Means what type of the responsibility has to be performed by that class is shown by the class diagram. So here we are saying that first structure is nothing but our module structure, and this module structure is totally static structure. Okay, because here whatever the data we are assigning, it is only executing that data, and that data or that particular data must be predefined. Okay, whenever we are assigning any type of the data to that particular module, that data is always be a predefined. So it just set to perform that particular work, or it is always ready to perform that particular work which is already predefined, and that is why these module structures are called as the static structures. Next one is nothing but the dynamic structure. The other structure is nothing but the dynamic structure. Dynamic structure means the structure or the structure which can execute the work at a runtime. At a runtime means at the time of the execution, if we change some inputs, okay, if we change some input, if we change some functionality, still those modules are able to work. But that is a not case in the static module. In a static module, they are going to perform the work which is predefined. As we say, they are going to perform the work which is predefined. Means at a runtime, if you changes some input or the information, then the static module will not be work. But that is not the case in the dynamic structure. The dynamic structures are also called as a component and the connector structures. Component and the connector structures means all those components can execute the services at a runtime. Okay, whatever the services we are having, okay, for those components and how those components are getting connected with each other, that is nothing but a component and the connector. And here whatever the system functionality we are assigned to them at a runtime, that is at the execution time, they are going to accept that information. If we changes some input, they are going to accept those changed input, and according to that they are going to perform their work, and that is why they are called as a dynamic. A simple example is here is nothing but a compiler. Okay, suppose if we are having a compiler, means most of the people knows what is meant by a compiler. Okay, so whenever we are executing our program, first we will try to check the errors. Okay, so we compile our program, we if some errors are there, then we remove those error at a runtime. Okay, so here means you are going to change the code. Okay, you are changing that code because you are removing the error, means some sort of the changes are required in your code, and again you are going to compile your program by making those changes, and still your program get compiled. Means if you are changing the logic at a runtime, still your program get executed. So that is nothing but a dynamic. And suppose if your program does not have any type of the error, then you are going to execute your program. Okay, so suppose your software is nothing but simple a calculator, so at a runtime your pressing 2 plus 2, it is going to show the result as 4. Now you are changing the inputs, you are now giving the inputs as 100 plus 100, so automatically it will show the output as a 200. The simple example is nothing but our basic calculator. Okay, in our calculator, whatever the data we are inserting and whatever the operations we are going to perform, it will always show the result, and it always shows the result as your input changes. Okay, if you are initially, if you are going providing the input as 1 plus 1, it will show 2. If you are changing the input as 2 plus 2, it is going to show 4. Means as soon as you are changing your input, still you are getting the correct output. Means whatever the changes you are providing, those changes will get accepted by that calculator, and the same thing is implemented in this structure, and that is why it is called as a dynamic, because at a runtime or at the execution time, whatever the data we are providing as an input, it will always accept that data and it will perform the work on that data, and that is why this structure is nothing but a dynamic structure. Okay, so this structure is also called as a component and the connector structure. Okay, because these components are nothing but they are the runtime entity which always ready to accept the data at a runtime or at the execution time. The next kind of the structure is nothing but the mapping from the software system. Okay, so third kind of the structure describes the mapping from software structures to the system's organizational development, installation, and the execution environments. So they are having the examples of, suppose modules are assigned to the teams to develop and assigned to places in a file structure for implementation, integration, and the testing. Means here we can say that this is nothing but a mapping. Means if you are developing a project, okay, you are going to develop a project, your team is getting assigned to develop a code. So whenever you are writing the code of that particular system, you are going to store that code in somewhere in the memory. So next time whenever you want to execute that code, you are going to access that code from that memory. So here we can say that we are mapping our code into that memory, or we are placing that code into the file, and from that file we are always accessing that data, and that is nothing but a mapping. Means whenever we are developing any software, side by side we are developing the documentation part. So whatever the code I have written, I have always maintained a documentation part, so that by reading the documentation I can easily get the information about that data. So here we can say that the software code and the documentation are get mapped with each other. Okay, they are getting the mapped with each other, they are getting the linked with each other, and then and only then I can access that data. Okay, means whenever I want to uh, change any type of the data into the software code, I must change that particular documentation also. So here we can say that this is nothing but the mapping. Okay, so this kind of the structure is nothing but which always describe the mapping from the software. Okay, so components are deployed into the hardware in order to execute. These mappings are called as the allocation structure. So here we can say that this is nothing but the allocation structure, because whenever you want to execute your system, at the time you have to install your system into your, or whatever the software you are having, you have to install your softwares into your computer system. So whenever we are saying we are installing a software into the computer system, is we are actually deploying that software into the hardware. Okay, your computer system is nothing but a hardware, that is your hard disk is nothing but a type of the hardware where you are going to install your software system. Okay, so those software system has nothing but the components which we are having, and that installation is nothing but we are going to deploy that particular software into the hardware, and hardware is nothing but your computer system. Okay, so this is nothing but, this mapping is nothing but the allocation structure. So here we have learned three types of the structure. First structure is nothing but the module structure. Okay, that is the static structure. Second structure is the dynamic structure, and third structure is nothing but the mapping structure, is nothing but a allocation structure. Okay, so although the software comprises an endless supply of the structure, not all of them are architecture. Okay, a structure is architecture if it supports reasoning about the system and the system's property. Okay, a structure is called as architecture, means we are having the n number of the structure, but not every structure is called as an architecture structure. It is only get to be called as an architecture structure if it supports that architecture. If it supports that architecture, or it will show some properties of that particular architecture, then and only then we can call that structure as an architectural structure. Otherwise, it cannot be called as an architectural structure. The reasoning should be about an architecture of the system that is important to some stakeholder. Okay, these include the functionality achieved by the system, the availability of the system in the face of fault, the difficulty of making the specific changes to the system, and the responsiveness of the system to user requests and the many others. Okay, so here that particular software architecture or the structure is must include the functionality achieved by that system. Means if your structure, here we are saying that the structure must support the system properties. Okay, or that structure must support the system and the system properties. So what type of the property that particular structure supports? So it must have the whatever the functionality achieved by that system, some part of that functionality must be in that particular structure. Second, the availability of the system in the face of the fault. Okay, so if there is a fault in any type of the system, then the structure must identify those faults and the structure must able to remove those faults. The difficulty of making the specific changes to the system, if the architecture is correct and the system is also that is the structure is also correct, then your structure need not be get changed. Okay, because if your structure get changed, automatically the architecture will get changed. So your structure must be rigid to that architecture. The responsiveness of the system to user request and many other. Second, the persons, if they are requesting something from your architecture, then your structure must able to identify that request and your structure must able to fulfill that request. So if your structure follows all these properties, then and only then we can say that a structure is an architecture structure, otherwise it is not. Okay, so thus, a set of the architecture structure is not fixed or not limited, because as we are saying that if in our the same example which we have previously, that is a building example, that is if your building is having 1 BHK flat, 2 BHK flat and the 3 BHK flat, so here we cannot say that a simple structure is an architecture structure. Okay, because 1 BHK, 2 BHK and 3 BHK. The structure of all those flats combiningly form the architecture, and each and every structure must follow those rules. That is the whatever the functionality achieved by the system is, every flat suppose must have the balcony, if I say. So in every structure I must provide the balcony. Okay, so in every structure must have the balcony. Second, availability of the system in the face of the fault. So if I want to make the complete changes into the system, so at the time the structure must be easily get modified. Third, if I don't want to change the architecture at that time, those structure must be rigid or they must be firm with that architecture. So here we cannot say that the state of the architecture structure is not fixed or the limited. That is, here each and every building has the different types of the flats. Okay, here we know that each and every building must have, can have the different type of the 1 BHK structure, they can have the different type of the 2 BHK structure, or they can have the different type of the 3 BHK structure. So here we cannot say that okay, this structure is a fixed architecture structure. It is not like that. The structures can be changed according to the architecture. Okay, the structures can be changed according to the architecture. So there we cannot say that only one type of the structure is enough for the architecture. It is not like that. As the architecture changes, the structure also changes, or vice versa. As the structure changes, your architecture changes. So here we can use again, a set of the architecture structure is not fixed or it is not limited. So what is an architecture is what useful in your context for your system. So here we can say that whatever are useful for our system, that things are nothing but the architecture. Okay, whatever the framework you are designing for your system and it works properly, then that particular framework can be called as an architecture. So architecture is an abstraction. Okay, so here we can say that because the architecture consists of the structure and structure consists of the elements and their relationship, then it follows that an architecture always comprises the software elements and how the elements are related to each other. Okay, so whenever we are saying the architecture, so architecture is not like that, it is just a complete framework. Okay, the architecture is not like that, okay, just I am having the border or just the outline. It is not like that. Whenever we are saying the architecture, so architecture is nothing but the elements or the structure which it has, and again those elements which are present into that structure. So all those combinedly called as an architecture. Means whatever the elements which are present into the structure and the relationship between those elements is totally again part of your architecture. So here we can say that an architecture comprises of software elements and how the elements are related to each other. Okay, so this means that the architecture specifically omits certain information about the elements that is not useful for reasoning about the system. So here we can say that the architecture specifically omits certain information about the elements that is not useful in the reasoning about the system. Means whatever the information is not we can say that useful, your architecture must omit that particular information. Okay, only the useful information must be shown by your architecture. The architecture is foremost an abstraction of a system that selects certain details and suppresses the others. So your architecture is like that, which must show the whatever the needed data is there, your architecture must show that data, but the data which is not useful, your architecture must hide that particular data. The architecture is concerned with the public side of the division, that is private details of the element. Detail having to do solely with the internal implementation are not the architecture. So in architecture, whatever we are showing, it must be the public side of the data. So here we are saying that whatever the needed, that part must be get shown, so that part must be your public side of the data. Okay, so beyond just an interface, though, the architectural abstraction in terms of its elements, how they are arranged, how they interact, how they are composed, and what their properties are that supports our system reasoning and for. Okay, so here we can say that whenever we are saying the architecture, or the architecture abstraction, it is nothing but the elements which are present in your architecture, and those elements must be arranged in some fashion that is they can pass the information from one place to another place. That is nothing but how they are going to interact with each other. The interaction between the elements is nothing but how they are exchanging the information, how they are composed, how they are arranged, how they are placed in that structure, how they are passing the information, what is the relationship in between them. That is all the things combinedly called as a architecture abstraction. Okay, so every software system has a software architecture. Every software system has a software architecture. So the system can be shown to comprise the element and relations amongst them to support some type of the reasoning. Okay, so every system can be shown to comprise the elements. Okay, in here we can say that in every system we can have the n number of the elements, and those elements must have the relationship in between them. Then and only then we can say that it can execute the data. So here we can say that all the system must have that elements which are related to each other. Okay, in the most trivial case, a system is itself a single element and uninterestingly and probably non-useful architecture, but an architecture nevertheless. Okay, so most of the system have a single element. Those single element system can be called as a architecture. Okay, even though every system has an architecture, it does not necessarily follow that architecture is known to anyone, and that is the basic rule. That is, every system has an architecture, but it is not compulsorily that the architecture is must be known to each and every person. Okay, suppose now most of the students are playing video games in their Android mobiles. Okay, now again we can say that the game, whatever the game they are playing, okay, in their mobile, that is an system stuff, that is an system software or the software system. Okay, that game is nothing but a software system. But here, whatever the structure that particular game has at the back end, that is not shown to the user. The person who is playing that game, he is totally unaware of the structure. He only knows, okay, I have to play this game and these are the components, but how they are going to communicate with each other, how they are relating with each other, how they are placing into the system, the user doesn't know about it. And that is the basic part, or we can say that intention of the system software, that is the structure must be hide from that particular user. Okay, so these are the things which are always, we can say that we are going to using a software system. So whenever we are designing a system software, that is a software architecture, so here we come to know that the architecture must have the structures. Each and every architecture must have the structure, and architecture can have the n number of the structures in it. Again, the structure is nothing but it is, you can say that it is simply a set of the elements. Whatever the elements we are using, whatever the data type we are using, those data types or those elements or those data types are nothing but the elements into the structure, and those elements must communicate with that with each other so that they can pass the information. And all those structures are combinedly from the architecture. Again, we come to know that there are many types of the structure, that is some structures are nothing but the model structures, they are static in nature, whereas some structures are dynamic in nature, and some structures are called as the allocation structure because they map your code with your data. And second, we come to know that every software architecture always hide the essential data from the end user. They always hide the essential data from the end user, and they only display the data which is required. Only the data which is required, that data is going to shown to the end user. So friends, on this note, we will stop here. Okay, and hope everyone is getting the terms correctly. Okay friends, so here on this note we will stop our lecture. Thank you very much for your patiently listening this lecture. Okay, thank you, bye.